All right, hi everybody. So today's main focus is going to be vectors. So after yesterday, yesterday will be the 8th of October, talking to some Group 1 students, I think it would just be a good idea to refresh what a vector is and how that kind of stuff works. So two biggest things for a vector. Number one, has a magnitude. Magnitude, fancy way of saying number. The second thing being direction. So vector, V for vector, by the way, has magnitude and direction. Okay, so displacement. Well, that's a vector. Remember, displacements have direction and magnitude. Displacement also means your change in position, where you end compared to where you begin. Okay, so we have to figure out those things. So let's take a look at a couple of examples. Okay, this will be really helpful for the homework. Let's say some object heads 300 meters east, 400 meters south, and then 100 meters west. Okay, so we have something that moves east, south, and west. Now, if I ask for the distance, yeah, you could add all three together, 300 plus 400 plus 100, and be good. But because I want to know the displacement, so let's say what is the magnitude of the displacement, life's a little more challenging than that because we have stuff moving in the x-axis, east and west, and something moving in the y-axis, south. So we actually kind of have to split these things up based on that information. So I can say x and I can say y. So x-axis, I have a positive 300, a negative 100. Y-axis, I have a negative, 400. Now, what I need to do is I need to add my like components. Because these x values because these two values on the x-axis, they can be added together. Because this one's on the y-axis, it cannot. So by summing like components, positive 300 minus or plus a negative 100 is 200, and this is just negative 400. Now, I am left with one x component and one y component. Once again, these two cannot talk directly to one another. So instead, I need to kind of set them up in a right triangle format because we have that fun-filled Pythagorean Theorem equation that you learned back in some math class that says, yes, if you have an x-axis and a y-axis, they can talk. So I'm going to kind of draw this out in a way that's similar to this. I have this 200 that's positive, so I can kind of show 200 to the right. And then I have 400 south, so I can show 400 going down. Lower right triangle, bada bing, bada boom. And there's my hypotenuse. So now we're just going to use some good old Pythagorean theorem. That's a spelling issue. Theorem. Boom. A squared, B squared, C squared. Okay? Sorry, my handwriting's gross right now. So, A squared, B squared, C squared. So, get my little calculator out, put it up on the screen. That gives me 200 squared plus. Now, it's really important I put this 400 in parentheses because sometimes these calculators will not cancel out the negative sign. Because remember, when you square something, it should always be positive. But sometimes the calculator doesn't do that. I don't know why. So we have this huge number, and we hit the second square root number, pop, pop. Hit second negative sign, gives me my answer, boom. And I get a C value of 447.21 meters. So, compared to where I started, to where I ended, that straight line path ended up being 447.21 meters. All right? Bada bing, bada boom. Now, another example, closer to question number 3, could look something like this. So we'll start object going north for 20 meters, east for 30 meters, but then it goes off at this weird angle of 24 degrees and goes 15 meters. Okay? So now we kind of run into an issue because, yes, we have an y-axis in 20, an x-axis in 30, but this 15 meters at an angle of 24 degrees, that's not along solely the x or y-axis, it's kind of along both. So let's tackle that in a second. Let's just start with a little chart. So x, y, x is 30, y is 20, not 40, 20. And so then we're stuck with this. So with this 15, okay, if you kind of think about it, ends up looking a little bit like a hypotenuse if I kind of continue out that dashed line. So I can go bop, bop, boop, 21 degrees, 15. X, y. Well now, gosh, I say now a lot. We have a right triangle where we know the angle, we know the hypotenuse, sine and cosine. Okay. So we'll start with the x-axis. X-axis, that's adjacent to my known angle. It's adjacent to the 24 degree angle. So we have sine of 24 is equal to x over 15. So x is equal to 15 sine 24. So you type that directly into the calculator how it is. So let me put the calculator on here. So I have 15 sine. Now a real quick thing to make sure you're in is make sure you're in degree mode. So I hit this little mode button right here. Make sure it says degree. So bop bop. See how degree is highlighted. I'll even hit enter on it. Boom. Second delete for quit. Or second mode to quit out. Oh gosh. This is embarrassing. Pop, pop. Boom. 24 degrees. And I get 6.1 meters. 6.1 meters. And we're going to do the same exact thing for cosine. Okay. But we're just now going to use, or sorry, for the y-axis, we're going to use cosine. So kind of the same thing. I do 15 cosine 24. The reason why I want to use cosine, oh, wait a second. That is embarrassing. We're going to do a little scribble, a little scribble, some more scribble, some more scribble. So turns out I forgot what is what. Let's try this again. So, x-axis is adjacent to my known angle because I know next to it. So that means I have to use cosine. Woo! That's embarrassing. So, let's try this again. So, cosine of 24 is equal to x over 15. X is equal to 15 cosine 24. So, we get 13.7. And if we run this all back with the y-axis, we get that 6.1. I'll do that in this little spot. Man, I should not have done this at the bottom of the screen. So sine theta equals y over 15. Y is equal to 15 sine 24. Y is equal to 6.1. Yeah, it's awkward. Now, meters. Now we're going to, next page. This bad boy. Get it a little clean, freshy fresh. So, we have, once again, this situation. 24 degrees, 15, 30, 20, 30. Ooh, that's a little cleaner. So I had a little mistake. I wrote cosine again accidentally. So we'll just ignore any of that last part just happened. And I'm not going to delete it out. I'm going to keep it in because it's embarrassing. We all need to live through embarrassment sometimes. Okay, so let's get our x and y components down. So x-axis positive 30 because it's going towards the right. This 13.7 will also be positive because if we kind of think about it, this vector is moving to the right as well, just moving down, so it's also positive. Positive 20, negative 13.7, because or 6.1. Gosh, man, it's rough going right now. Negative 6.1, because as mentioned, it's moving down. So add these two things together again. So 30 plus 13.7 is 43.7. 20 minus 6.1 gives you a 13.9. Okay. So now we can create a brand new right triangle. So this positive 43.7. This silly positive 13.9. So we then can create our right triangle. Man, I am... Oh my gosh, I'm losing it, kids. Boom. Okay. So find this. So once again, little Pythagorean Theorem. So 13.9 squared plus, what did I say, 43.7? 43.7 squared. Square root it. And you get 45.86. Okay. Meters. Now, I could, in a question, say, hey, what is the direction? So, like, what is the magnitude? So that's this number. This is your magnitude. But I could also ask, what is the direction? So if I say, what is the direction? I really want to know what's the angle. What's the theta? Okay. So in this case, I know these two things. I want to find theta. That would be my tangent. So tangent of theta is equal to your opposite over your adjacent. So in order to find the angle, you divide both sides by the tangent, but theta is equal to what we call the tangent inverse of opposite over adjacent. So in this case, I have tangent inverse of 13.9 over 43.7. Theta is equal to, so tangent inverse of 13.9 divided by 43.7. We get a 17.64 degrees is my direction.